Welcome to On the Job with Finger Lakes Television, where we focus on the newest generation in the workplace. We'll take you on a road trip to offices, factories, and farms across the Finger Lakes region to see how millennials are finding their niche. I'm Dinah Brennan. As your host today, I'm going to take a look at a company in the village of Clifton Springs in Ontario County called GW Lisk. More than 600 people work there, making valves, flame arresters, and solenoids for military, aerospace, and other industries. You'll find parts made by GW Lisk in construction equipment, oil and gas rigs, and nearly every aircraft in the sky today. GW Lisk is what we call an advanced manufacturer. It's a term that sets companies like GW Lisk apart from traditional manufacturing. Traditional manufacturing might make you think of people doing routine tasks on assembly lines day after day. Advanced manufacturing is about using computers to make parts that meet very precise specifications. It's also about continually looking for ways to make the manufacturing process more efficient. Because machining is computerized, modern factories have to be air-conditioned, and much of the work is done inside enclosed machines. We're going to take a look at one of the production areas at GW Lisk. Along the way, we're going to meet two employees, Jamison Case and Daniel Alden, as well as their supervisor, Dave Phillips.
I'm Dave Phillips, training manager at GW Lisk. GW Lisk is an original equipment manufacturer of valves, solenoids, and electronic sensors called LVDTs. Here in Clifton Springs, it's our corporate headquarters. There's about 700 people that work here in Clifton Springs. GW Lisk also has a manufacturing facility in Ireland with approximately 150 people, and manufacturing in China with about 35 people.
My job title is a CNC machinist, and I get a blueprint and I make whatever that blueprint tells me to make out of metal, plastic, whatever the material is that they want me to make it out of.
And advanced manufacturing is really a term that describes where manufacturing is headed in the last 20 years. I guess the best description is this manufacturing that has taken advantage of computer controls and all the latest technologies that will help the manufacturing process be more productive and also allow us to work to much tighter tolerances and produce a better product.
From scratch, I start with a raw piece of stock, whether it's a whole bar of it or maybe like an individual slug maybe, and I take whatever tools I need to either make the outside, inside work. I personally do a lot of military aerospace parts, and I know the company in general, we do parts for a lot of military contracts.
Jamison has come quite a ways through his experience here. He started in our advanced manufacturing training program with really no background in machining. He did very well in that class. He advanced through that class. He started in our machine shop, and he now sets up and runs some of our specialized equipment. It's called a Swiss machine. Like Swiss watchmaking, it's very precision, very small, intricate parts. And he sets those machines up, makes the parts to them. He uses all the inspection equipment that's required to make sure his parts are within their tolerance specification.
Hi, my name is Dan Alden. I am a CNC machinist at GW Lisk, and my responsibilities are setting up machines and running parts from start to finish and passing them through the quality inspection hub.
Dan Alden came through our training program, and Dan excels very well in the machine shop. He has a very good grasp on the technology and the aptitude for machining. So he's done very well in the machine shop, and he has advanced at a very quick pace in his career here.
When I make a part, we start out with a blueprint, and we're responsible for setting up the machine, putting in all the tools, running through the part, and getting it passed through the first article inspection process, and then running out the job till it's complete. It's important that the parts are very precise because a lot of them have flight safety characteristics that have to be checked 100% for zero defects. I
went to school for engineering for a year, and then when I was home for the summer, I work, my family owns a store right around the corner, and everybody told me I would love it here, so I gave it a shot, and sure enough, I like where I landed.
I found out about this job through an ad, and I joined the training program through FLTV with GW Lisk for 6 months to be trained here on site, and then I got a job.
So training that's required to start here as a machinist would involve going through our advanced manufacturing machinist program. That's a 6-month program. It's 500 hours of instruction. That's 4 hours a day, 5 days a week. It involves classroom training with industry-specific topics like technical math, geometric dimensioning and tolerancing, machining basics, metrology, and then there's lab instruction. And on the lab instruction, we start with basic machining. We teach somebody about machining and how the machining operations work. And then we advance up into working with computer-controlled equipment. And the final stage of that is working with equipment that is the same equipment that we have on our manufacturing floor. It prepares the student to come into our company to be able to work to the tolerances. Some of our tolerances go down to the micro-inch or millionth of an inch. So it prepares them to be able to work to those tolerances, to understand those tolerances, and to be able to use the equipment that will check those parts and make sure they're to their spec limits.
As you can imagine, you need some training to work in machining, but you don't need a 4-year college degree either. Both Jameson and Daniel took part in a 6-month advanced manufacturing machinist program that Finger Lakes Community College runs in cooperation with GW Lisk. A lot of people think of community colleges as an opportunity to save money by taking introductory classes close to home and then transferring to a 4-year college. That's true, but community colleges also have a range of programs that can prepare people for jobs fairly quickly. Some can take just 6 weeks or 6 months to complete. Community colleges also have 1-year certificate programs, for example, for paramedics and landscapers. A great way to learn more about manufacturing today is to take a tour of a plant or attend an information session. Many high schools now offer tours of manufacturing facilities so you can see what it's really like. If you're out of high school, call a community college and ask to meet with a counselor. Let's turn again to GW Lisk to learn a bit more.
I had no idea what machining was, what the whole process was behind it. I learned everything right from scratch.
When I first started here, I was just running parts mostly. Every day, just running maybe one machine, and now I run either 2 machines or I'm doing setups on a regular basis.
First, you have to know how to look at a blueprint and be able to figure out what dimensions are where, and you basically have to know how to choose what tool and what process in order to make the final part, and you have to be able to gauge how to go about making it so that you don't run into oh, this is impossible when I get to this step. So my year of college did help me a lot because there's a decent amount of math that goes into it, and it's kind of like trigonometry. I thought I'd never use that after high school, but here it is, and definitely did help to have the year of college under my belt.
The FLTV program is a great way to get started in a career in lieu of getting a college degree. You can get right to work and have a great career ahead of you.
I think the class overall gave me a really good base for we started from the basics, from nothing, and worked our way all the way up to where I'm at now. So they taught me everything in between. So
a high schooler or a young person that's interested in machining or manufacturing, I would say they should take technology classes in school, stick with math, do well in English. There's a lot of communication in manufacturing.
It's a really big group effort. If we didn't communicate with each other, there would be a lot of mistakes going on. You really have to be a team player.
In high school, you should study algebra very well. It's very helpful, and take shop classes. Hands-on, get used to working with your hands and getting a little dirty.
Some of the other things that may serve them real well is join a robotics team. First Robotics will give them first-hand exposure to many of the skills needed in manufacturing. They will learn about machining, manufacturing, design development, automation, robotics, and working on a team to come together to create a robot that can do whatever task it is for each year's competition.
I believe in a month or two I will be working here for 2 years now in the CNC department. What I really like about the job is the fact that I can come in every day and learn something new pretty much every day, and I never have to have the same experience, so it keeps things fresh. My job has changed a lot over that time because I started off, they let me run the machines, but now I'm to the point where I get to put tools in and set up right from the start. So I get to see the entire process of how from start to finish a part is actually made. So instead of just hitting the go button and having it run through.
So qualities for somebody to be successful in manufacturing, advanced manufacturing, would be somebody who is a critical thinker, can practice critical reflection, they're good at planning, they can perform in a busy environment, they're willing and able to work on self-directed teams, they can pay close attention to detail.
To do very well here, you have to be motivated, an aptitude for picking up things quick, learn fast, work hard.
It's really important to have that good communication, because if I'm having issues with one part, then I hand it off to some other guy and I don't let him know what's going on, he could run a bunch of bad parts, and then it's on both of us. So it's kind of like you need to keep up on what's really important. So
we have to work as a team because we have 6 machines and usually 4 guys, and we try and keep all the machines going. We have to communicate and work well with each other.
As far as my pay goes, I'm satisfied with my pay. They compensate. I have really great benefits, dental, health, and all that for a really good price. So I'm satisfied with what I'm being paid and all the benefits I'm offered.
Being a CNC machinist is very rewarding and can be frustrating trying to figure out problems and troubleshoot machines, but a very good career opportunity to work at. They take care of us. The benefits package is excellent. You can look out in the parking lot, you see a lot of brand new trucks.
I hope you've enjoyed seeing inside a modern manufacturing facility with Jameson and Daniel. If you are interested in learning more, you can start with the company's website, www.gwlisk.com. Many manufacturers in the Finger Lakes region are preparing for the retirement of the baby boomer generation. They are encouraging more young people to get into machining and engineering. GW Lisk is one of about 36 local companies that have taken the 5% pledge to create 5 internships or temporary jobs for every 100 workers they have. It's a great way to learn more about a career before making a permanent decision. This show is a joint project of the Finger Lakes Workforce Investment Board, Finger Lakes Community College, and Finger Lakes Television, the public access TV station for the Finger Lakes region. You can find out more about all 3 organizations and the 5% pledge by using the contact information at the end of this show. I'm Dinah Brennan. Thank you for watching. Please be sure to join us for the next episode of On the Job with Finger Lakes Television.